Hello everyone, hope you're doing well. Welcome back to another Algebra 1 video. Today we are going to be conquering the insurmountable beast of compound inequalities. And before we begin, I'd like to mention this is my last MS Paint video. I'm going to be moving on to a new software called Microsoft Whiteboard, I believe it's called. And my videos will start to look a lot cleaner. So expect slightly less chicken scratch and not this annoying huge bar at the top. Okay, now that we've gotten that out of the way, we can start with this lovely task of solving and or inequalities. And we will start with the or. So with or inequalities, basically you have two conditions and you have to satisfy at least one of them. The range of solutions, the solution you pick has to satisfy at least one of the ranges of solutions. You'll see what I'm talking about when I solve it. For and inequalities, it has to satisfy both conditions at the same time, which will often lead to a very limited range of numbers, or sometimes even a very large range of numbers, depending on the problem. So with all compound inequalities, you start by solving both conditions. So let's start that here. Negative 3 times x. You know what? Let me just write it out here as I say it. Negative 3 x plus 4 minus 2 over 5 is greater than 2x. So the first step to solving this is multiplying both sides by 5 to get rid of the 5 in the denominator here, so that we're dealing with no fractions. That is going to give us negative 3 times x plus 4 minus 2, right? Yeah. And on this side, we will have 10x. Now, the next step, this looks like a 7. Oh my goodness. Okay. The next step is adding, I want to say 2 on both sides. Yeah. So we're going to do that here and here. So negative 3 times x plus 4 is greater than 10x plus 2. Next, we are going to distribute that negative 3 to the x and the 4. So when we do that, we're going to get negative 3x minus 12 is greater than 10x plus 2. Now, as you get more comfortable with solving these equations, you can sort of do them in your head, like do two steps at the same time in your head. So what I personally like to do is I like to subtract the 10x from both sides and then add the 12 on both sides at the same time. Sort of save me some writing, save me a step. So that's what I'm going to do here. So we're going to do minus 10x on this side, minus 10x on that side, and we're going to do plus 12 plus 12. That'll ease things up for us, sort of. So it gets eliminated here. You get plus 14, or sorry. Then on this side, the 10x gets eliminated. And then here, we're going to be left with negative 13x is greater than 14. 2 plus 12 is 14. So now you must call back to the flipping the sign rule when you divide or multiply by a negative number. So we're going to be dividing by negative 13 and dividing by negative 13, so both sides, and x is going to be less than negative 14 thirds. We'll leave that as an improper fraction. Okay, so this entire equation, I'll underline it in green, boils down to this right here. Now let's do the other condition. It's nice and easy, not as complex as the one we just did. So 5x minus 9 is less than 4. Plus 9 both sides. That leaves us with 5x is less than 13. And we can divide by 5 now. And what we're going to get is x is less than 13/5. Alright. So now that we have our two conditions all simplified and set up here, we can now begin to graph these. And graphing and or inequalities gets pretty easy once you get the gist of it. So I'm going to draw me a number line here in yellow. I'll draw it down here. And now we have to determine what range of values we need. So 13/5 is basically what, like 2 and 3/5, and negative 14/3 is close to -1. So I guess we can sort of go with a middle of the line number line here. 1, 2, and then -1, -2. How about that? Make some more tick marks. Okay. Now what we do here is we graph both of our conditions on the number line individually. So we're going to start with x is less than -14/3. Because it is not including -14/3, remember that we use an open circle to plot that point, right? So -14/3 would be around here, or sorry, -14/13 would be around here somewhere, very close to -1. And because it is less than, it would be going in this direction. So we'll just plot it that way. This is good. Okay. And now we will plot our x is less than 13/5. So 13/5 would be around here. And we're going to draw a line going this way. So the thing here that makes it different from an and inequality, as I said earlier, is that you don't have to satisfy both conditions at once. You just have to make sure you're satisfying one of them. So what do I mean by this? A value of 1 will satisfy this entire thing, because it's this inequality, or 5x minus 9 is less than 4. Even though that value of 1 is outside the range of solutions for this equation, which is too long for me to say, but even though it's outside of the range of solutions for that one, it still fits into this one, and it counts for both of them because it's an or inequality. You only have to satisfy one of them at a time, If you satisfy both of them, that's great. Go ahead. But you don't have to satisfy both of them. So really, these range of values are also satisfactory for the inequality, for this OR inequality. All right, now I hope you understood that. Let's move on to the AND inequalities. What's tricky about the AND inequalities is that you have to satisfy both conditions at the same time, and it can be a pain in the butt sometimes. So let's start by solving out each of the conditions. I'll do the left one. I'll make the solution of the left one in red, and the right one we'll do in like blue or something. Okay, so 7 times x plus 9 minus 1 is less than or equal to negative 2x minus 4. Nice and easy. Okay, so first let's start by doing plus 1 on both sides. Plus 1. And eliminate 7 times x plus 9 is less than or equal to negative 2x minus 3. Now what we do is distribute. So we're going to get, so if you multiply that out there and out there, you get 7x plus 63, huge number, is less than or equal to negative 2x, 2x minus 3. And now I'm going to do the same thing that I explained back here, where I do both steps at the same time. So plus 3, or we'll actually do plus 2x on this side, and then minus 63. Okay. And doing that, we get 9x. That gets eliminated. Is less than or equal to. This also gets eliminated. Negative 66. Yeah. Alright. And now we're going to do this in red. Divide by 9 on both sides. And we're dividing by positive here, so we don't have to flip the inequality sign. Although a negative is being divided by a positive here, that doesn't mean you flip it. It has to be, the divisor has to be a negative. And we can simplify this fraction if we divide by 3, the numerator and the denominator. So we get negative 22 over 3. Yep. Okay. So this is our simplified condition for the left one. And now we're going to be doing the right one. X minus 3 is greater than 2. That's just some preschool stuff. I don't even think I need to write that one out. X is greater than 5. Just add 3 on both sides. Plus 3 plus 3. Okay. Now this is the simplified condition for the right one. So we have 5 and we have negative 22 thirds, which is around negative 7. So this is going to be a pretty wide number line. We'll make it in yellow again. And okay. I think I might do this in twos. 0, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 2, 4, 6, -4, -6, -8. Alright, so now we graph each of these individually. So let's start with the left one. And we're going to graph it in red. So because it is less than and equal to, we use a closed circle for this one to plot the point. -22/3 is around here, I would say. And it is less than, correct? Yeah. So it would just go on this way. Okay. And now we can graph, that is so messy. Now we can graph x is greater than 5 in blue. And that's going to be an open circle because it's only greater than. Did I say x is less than 5? I mean x is greater than 5. And it's going to go this way. So we have a pretty clear answer here that no value falls in between both of these. So because nothing satisfies both conditions at the same time, since it's an and inequality, you need to have that. And because you don't have that in this situation, we're going to have no solution. No solution. So the final answer for this and inequality is no solution. We did all of that just to get no solution. The final answer for this one, I don't think I said what it would be, but it would basically, it could just be either of these actually. It could be any of these values you see here. So, what should I do this in? Green. It can be any of these. Any of these. Going on and on and on. It can be any of those solutions. Except nothing back here. Because once you go back here, this is the danger zone. Alright. Can't have any solutions back here because it doesn't satisfy either inequality. Right? Here, you have no solution because none of the values fall within range of each other. None of the ranges of solutions. So there is no value that satisfies both equations at the same time. Thus, you're going to have no solution. So I hope you found this helpful. Next video, I believe we're going to go over double inequalities. So I'll see you then.